There it goes. All right. Okay, so let's continue with this. I didn't put the name of it on here, but what was it like equation of a line or something like that? Graphing linear equations is what it was. Okay, I'm not going to write that on there, but the title, let's write it on there. Graphing linear equations. So what, we had like a formula, an equation. We had an equation yesterday. Do you remember what it was? Good. AX plus BY plus C equals 0. What equation do we call it? We gave it a name. Yeah, I think I call it the general form. I think some people do call it standard. All right, so it's the general form. We'll just call it the general form. All right, so you just put it in order. AX constant equals 0. And we learned how to work with that, right? If we wanted to find an x-intercept or y-intercept, this is what we would use. We would use this little formula right there. And again, I said yesterday it was like a little underrated way to graph something, but it's a nice way to graph. You just got to put 2 points, find the x-intercept, y-intercept, and then put a line in between them and you're good to go. But, and I mentioned this yesterday, what is the equation that we're most familiar with? What do we call that thing? Slope-intercept form. Good. You've done that in Algebra 1. You definitely did it in geometry because I taught it to you. And I'm sure you've done that in Algebra 2. And we're going to do it again in pre-calculus, all right? So it's definitely important. Shows up in a lot of different areas. So there we go. Oh, man, somebody, well, I wouldn't call him a friend. Some guy I know. He put a meme on there. He says, well, another day went by and I never used algebra. I just want to smack him in the face. Not literally, figuratively. But what I want to say is, okay, another day went by. Did you drive a car? Did you go inside a building? Did you use electricity? Did you use your phone? Did you do any of those things? Well, thank algebra for that, because if it wasn't for algebra, you wouldn't have any of that stuff. But I stay out of that kind of stuff on Facebook, so I just said it to myself. And hopefully he heard it, but I doubt it. Anyway, but it's true, all right? A lot of the stuff we're doing, you may not do it the rest of your life. Did I ever tell you this story 2 years ago? This kid came to me. It was a different school. It was at Newcastle, when I was at Newcastle. This kid came to me, and it was a girl, and real nice, sweet girl. She says, I said, where's your homework? Turn in homework. She says, oh, I didn't do it. My mom said I didn't have to do math homework anymore because I never used algebra my whole life, and you'll never use algebra, so you don't have to do your homework. That's what a mom told a kid that's in my class. I'm like, well, too bad. You'll get a 0 every single time you don't do a homework, and that's going to affect your grade and all that kind of stuff. So that was my comeback for it. But just because you don't use it, actually do it, right? But there are people that use it all the time, right? But just because you don't, you still feel the effects of it. If there were not people out there that did math and high-level math, and you can't do high-level math until you start doing high school and basic algebra stuff, right? You can't do algebra unless you can count and add negative and positive numbers, right? It's all baseline. So just because we don't use it in our life doesn't mean it's not important, okay? I think it's very important. It helps us think. That's one thing it does, all right? It really helps us think, and it helps us become a problem solver, even if we don't use it the rest of our life. So never post that meme that says, all right, another day went by, and I never used algebra, all right? Anyway, just thought I'd say that. Don't know why I started thinking of that, but I did. All right. So what is the slope-intercept form? You should know it. Somebody tell me. Y equals mx plus b. Yeah, that's something that you'll probably always remember. All right, it's got a couple things in there. It's got a couple letters. Well, it's got 4 letters, but 2 in particular. It's got this one right there. What does that stand for? That's the slope. Why is it m? That's stupid. Why don't they make it an s? I don't know. S could stand for other things. Like in physics, a lot of times the distance that something travels, they actually use the letter S for that. Isn't that weird? It depends what book you look at, but sometimes they use the letter S for like the distance traveled. So maybe that's why they didn't call it S. I don't know. But I looked it up a long time ago. Do you remember what the conclusion was? I might have talked to you a couple years ago about it. And nobody really knows. I mean, nobody like really came together and said, this is why we use m for slope. Okay, it's kind of unknown, but people think it came from some Latin word, and the word starts with m, and it kind of means mountains, right? Mountains are steep, right? So that's good enough for me. So when I think of m, I think of, okay, I got steep mountains. I used to hike, right? Back when I taught you, I think I was still hiking, but I'm not hiking anymore. But you go up steep mountains, and that's what I like to think of is the m. It probably really didn't come from that, but it could have. I'll just say that. All right, what is that? What does the B stand for? It's a little b. It's different than this B right here, that capital B. So it's not the same number. All right, what does that stand for right there? Remember?
X-intercept.
Y-intercept. Yeah, it's the Y-intercept. Okay, so it's the Y-intercept. Do you see the X and Y right here? Basically, the X and Y stands for any point that lies on that particular line. All right, so I could take any point on that line, find the X and Y, and I can plug it in, and it'll make this thing work. Okay, so if I know the slope and I know the Y-intercept, I can find any point on the line and put it right there, and they all equal. Okay, so that's really what that stands for. Let's talk about slope a little bit. What's the one thing you always remember about slope? It's something rise over run, okay? So it's rise, that's easy. It's got a nice little alliteration here, which means they both start with the same letter. So rise over run. But when you get a little bit more into it, do you remember what we did in geometry? And you probably talked about this in Algebra 2. We don't just stop at rise over run. The rise goes up and down the y-axis, right? The run goes across this way on the x-axis. So we say it changes, right? You go from one point to the other. What letter, it's a Greek letter, what letter is used for the change in something? Anybody remember that? Delta, very good. And what does the delta kind of look like? Basically, it looks like a triangle. I think one of these sides, I don't know which one, maybe this side right here is a little bit thicker, but we don't usually go to the trouble of making it a little bit thicker. You just draw a little triangle, little equilateral triangle, and this is the change in y over the change in x. So let's write that down, change in. So it means the change in y over the change in x. So like when you get a little bit older and get a little bit more involved in your math, your teachers may not say rise over run. They might say the change in y over the change in x. All right, that's a little bit more uppity, right? A little upper level things, but it means the same thing. Okay, so delta y over delta x means the same thing. What does that mean to change in something? So if I went from a point from here to here on the y-axis, and if this was at 7 and this was 3, the change is what? That distance, right? That's what the change in y is. How do I find that? Do I add them up to find that length? What do I do to find that length? I subtract them, exactly. Okay, I would have subtracted them. Wouldn't you agree? If this was like at the 7-mile marker, all right, and this was the 3-mile marker, how far did you drive from 7 to 3? 4. How did you get that? What math did you do? You subtracted, you minused, okay? Now, you could go the other way too, right? It doesn't matter. But it does, well, I'll do this in a second. So here's what we do. Most books put y2 minus y1. I'll do that, but a lot of times I just write y1 minus y2. But I'm going to go y2 minus y1, all right? So these are on the y-axis right here, okay? So that's one of my y points. That's my other y point. How do I find the distance between them? I subtract. What about going on the x-axis? Same thing, right? So this and this, whoops, I'll call this x2 and I'll call it x1. So I would go x2 minus x1. Now, it does not matter if you go the 2 minus the 1 or the 1 minus the 2, as long as you go the same way on the x and the y. Remember that? Right? As long as you subtract in the same direction, it doesn't matter if you go, I'll just put this, y1 minus y2 over x1 minus x2. How can you remember that the y goes on top? Because a lot of times let me say this. X comes before Y, correct, in the alphabet. So a lot of times students think that the X should go on top. Why does the Y go on top? Because it's the rise. That's right. Rise over run. And that's the way that we've figured it out. I mean, people a long time ago could have made it run over rise, and that would have been fine, but they didn't. They said it was rise over the run, and that way we can all agree on doing it the same way, finding the slope the same exact way, okay? So that's why it's y over x, because it's rise, which is the y, over the x, which is the run. All right. It was a lot easier when you just learned rise over run, wasn't it? But there's a bunch of stuff in there. So with all that said, let's do a graph. These are easy graphs. You just wait later in this year on some of these graphs we're going to be doing, all right? You're going to wish you're going back to this stuff right here, all right? So not to scare you, but it probably did. Let's do an example. This is example 3 in the book, all right? And it says, here's where it says graph, and they tell you how to graph it, okay? So we're not going to do it by x and y intercepts. Do you remember when you first learned how to graph, you did this thing? Right? You put an x and a y, and you picked a bunch of x's, you put it into the equation, figure out what your y is going to be. We're not going to do that. Now, there's nothing wrong with that, because really, a lot of times, we'll use that method on stuff that's really super complicated. All right? We'll use that method. So there's nothing wrong with that method at all. All right? But we're not going to do it right now. We're going to graph using slope-intercept form. Slope-intercept. All right, a couple of you guys have your heads down. It'd be nice if you got them up. If somebody's got their head down around you, kind of give them a little tap. Don't pound them on the head. Just give them a little tap. Tell them to wake up. I know it's at the end of the day. I get it. I'm tired too. But we got to deal with it. So here we go. Here's the equation. Y equals 3/4 x minus 2. I really hope at this point in your math career, this looks super simple and you can get it. All right? Is it? All right, what am I going to do here? So I'm going to grab this graph right here. And then make it a little bit bigger so I can see it. There we go. All right, so now we're ready to go. Really, when it's in this form, it's about the easiest thing you could graph, almost. So what are we looking at? We're looking at the two things that I circled earlier. First of all, we look at the y-intercept. That's the first thing we're going to plot. All right. What does that mean? The y-intercept. It means where the line crosses what? The y-axis. So where does it cross the y-axis? At -2. So I come down here and I just put a dot at -2. Is this coming back to you? I hope so. All right. And now, what's the second thing that we plot? The slope. Okay. So we do the y-intercept first, then we do the slope, because we need a starting point, right? If I just said slope, like, oh, where do I start? I don't know. Well, I start at -2 on the y-intercept, right? So what does that mean? It's rise over run, correct? So I start here and I rise, watch, 1, 2, 3, okay? And why did I go up?
Because it's not negative.
Well, because it's positive. Yeah, I would rather say that. It's positive, right? So I go up 3, 1, 2, 3, and I go where? To the right. How many places? 1, 2, 3, 4 places right there, okay? Put 2 dots. That's all you need are 2 dots, right? All you need are 2 points to make a line. And then you just connect them and stretch it out a little bit. Don't just go from point to point. You could go all the way through the graph if you wanted to, or you could just stop right there and do it like this. And there it is. That's the graph to this equation right there. It's already in slope-intercept form. Make it really nice. You know what they're going to do, though? They're going to put it in another form, and you got to put it into slope-intercept form, okay? You've probably done that before. So let's do that right now. So this is B. So here's the equation they're going to give you. They're not going to put it in slope-intercept form. But it's not that hard to put it in slope-intercept form. It's super easy to put it in slope-intercept form. So what do? How do I put this in slope-intercept form? What do I got to do? Subtract y? I wouldn't do that, because if I put it over here, I get a negative y. In one step, I could do this. What is it?
Subtract 2x.
Yeah, subtract the 2x. Now, am I going to go 5 minus 2x, though? Nah, because look at the slope-intercept form. The slope-intercept form up here, look, the mx is before the constant, the y-intercept, right? So what's going to be your y-intercept? It's the 5. So I basically want to push that over and then put the mx right here. How do I get rid of that negative 2x and move it to the other side? Oh, I just gave it away. How do I get rid of that 2x? And yeah, so I subtract 2x from both sides, so that becomes negative 2x. And then I got y by itself. That's the easiest way to solve that. You could have taken the y and put it over here, but then you got to put the 5 over there, then you got to get rid of the negative sign. Too much. One step, boom, I'm done. Not always going to be that easy, but this one is. So now, let's do this in a different color. Let's go blue. All right. So this is the first thing that we plot. That's what we say, plot the points. Right? So y-intercept is 5. So I go 1, 2, 3, 4, 5, put a dot or a point. I shouldn't say a dot. It's a point. So you put a point right there. And then we got to figure out what the slope is. What's the slope of this? Is it just negative 2? I need a rise and a run, don't I? It's over 1. That's right. Okay. So it's negative 2 over 1. So I start here. I'm going to go down 2 this time because it's negative 2. So I go down 2, 1, 2, and I go to the, nope, I already went down. I already did the negative. If I go to the left, that would make that a positive 2. I got to go to the right. All right, so there it is. There's the 2 points, and I connect them. Extend them out a little bit. Don't just make a short little stubby line segment. All right, put some arrows on it because they are lines, and you're good to go. And that's it. That's how you graph that. Couldn't be easier, right? Let me do a couple more things. We got, I'll try to keep you about 5 more minutes. Let me grab this.
Because no, but I'm saying because it's basic. No. I mean like.
All right, here we go. It doesn't matter, left or right, doesn't make any difference.
I'm looking at the screen. This is right. This is left for him, but he's facing this way.
He's looking at it.
I'm still looking at the screen the same way you're looking at the screen, so.
You guys understand what I'm saying?
No, we do it.
It's not.
All right, I got 4 of these things I'm going to do, so I'll just move it down here. All right, everybody watching? Here we go. Enough nonsense. Let's pay attention right here. All right, if I had a line like this. Oops. Ooh, I made those red. That was dumb. That's okay. All right. So there you go. So if I had a line like this, tell me, now you don't know the numbers, okay? You have no idea like how far you rise, how far you run, but give me the sign of the slope. Sign. Yeah, so if I went from one point to the other, what's the rise? The rise is just sign, positive, and the run is what? Positive. So I got a positive over a what? Positive, which is positive. All right, so that's a positive slope. So anything that goes from left to right and it goes up, that's a positive slope. What do you think this one's going to be? That's going to be a negative slope. I won't put the arrows just because of time. So if I took 2 points on here and I went rise over run, so this rise is what? I'm going down, so that's negative. And this run is what? Positive. So what's negative over positive? It's negative. So this is a negative slope. All right. This is all old hat for you, isn't it?
Yeah.
I hope so. Because if it's not, you might be in the wrong class. Let's go do that. All right, let's do another one. What if I had, let's put it in red this time. What if I had a line that was like this? What kind of line is that? It's horizontal, right? It's horizontal.
Or is that undefined?
Well, let's think about it. Watch. Let's go from one point to the other. Let's go from one point to the other. So if I go from this left point to this point right here, how far do I have to go up to get from here to here? I go 0, right? So I go 0 over however far you go. How far is it? No? far to the right, I go up 0, but I go to the right, whatever that number is, right? If I counted it out, we'll just call it x. What's 0 divided by anything?
0.
It's 0. So this is a 0 slope. Do you remember me telling the story about me rappelling when I was in ROTC in college?
You're ROTC veteran?
The veteran. I didn't complete the ROTC program. I took it 1 semester, and that was it. Okay? So watch. Look at this. Let's go from the top to the bottom. It doesn't matter which way we go. Top to the bottom. So rise over run. So how far did I rise? I don't know. No, not X. I'm going up and down. So I'm not going across. So what is it? How far did I rise? Y. Right? Whatever number that is. Whatever number it is. I don't know what the number is. I didn't put any numbers in here, right? So, but it's Y. Okay, that's the rise. Over the run. So if I rise to go from here to here, how far do I run? 0. What's any number? Could this be any number? What's any number divided by 0? It's undefined. It's not 0. It's undefined. And I didn't hear anybody say 0, so that's good. It's undefined. All right? Or we say, here's what we normally say. This is 0 slope. This is no slope. All right? And some people look at this and say, well, 0 slope is nothing. So 0 and no is the same thing. Is it? No. This is different. That's a lot different than that. You don't remember my story about me? You do? Say, look, here we go. Here's my story. I like to tell it. Watch. So I was rappelling, right? You got a rope, and you got all these boulders. All these boulders down at the bottom. Shh. If you're not going to listen, I'll just give you double homework. So look. And I was going backwards, so I was looking this way. And so I'm going backwards. And you got to let out some slack on the rope. And eventually, I was like this, right? Hanging on to a rope, all right? That was me. So you're supposed to be perpendicular, right? I was a math major. I knew what perpendicular was, right? So like this. It's supposed to be like this. But the guy says, let out a little more, let out a little more. And I was like, and so here's what I'm doing. I'm going like this, going down. Then all of a sudden, guess what's going to happen? Yeah, my feet come out from under me, and bam. My head is facing down toward these big old boulders. All right, must have been 100 feet down or something. It was crazy. And everybody, the dude's like, don't do anything. Whatever you do, just stay right there. And then all of a sudden, I saw all the other people, right, that were doing rappelling. I saw them all come over and look over the cliff. And I saw all these faces staring at me as I'm completely upside down, looking up through my feet at these people looking at me. I was so embarrassed. I wasn't even scared. I was just embarrassed. And I was like, and they're getting all harnessed up to try to come and rescue me. And I was like, there's no way I'm going to let these dudes rescue me, right? So I start bouncing a little bit with my feet against it. And finally, I got enough where I'm like this now. And man, I just said, see ya. And I went boom, 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 all the way down to the bottom like I was supposed to. The dude down the bottom was like, man, you had a rough start, but you got down here faster than anybody else did. And I was like, oh, it's so embarrassing. I mean, it was fun, but I freaked everybody out. But it really wasn't my fault. The guy kept on telling me to let out my rope. But anyway, at the bottom of this, with that story, why do I tell that story? Because if I would have fallen and I would have hit these boulders, that's all it was. It was just sheer boulders at the bottom. I would have been what? I would have been undefined, okay? They wouldn't have been able to tell who I was, all right? So this is no slope or undefined slope. There's my rappelling story. I tell it every year, every time I talk about undefined, and you guys can go.